Today we're going to talk about multiplying decimals, okay? So the very first example we have is an area model, which is, they're okay for breaking down some stuff, but I prefer the algorithm, but we'll do the area model anyway. Um, so let's say when we solve the first one, okay? Especially when multiplying decimals, we'll go over it later down here, but essentially what you want to do is kind of ignore the decimals until the end. Okay, so here we have 2.7 times 1.4. I'm just going to write that as 27 times 14. Now, when the decimal comes into play is after, right? So I have one number here or digit here on the right side of my decimal. I have another digit here on the right side of my decimal. So that means once I get my final product, I'm going to scoot that decimal 1, 2 to the left all the way from the end of our number, okay? So 7 times 4 is 28, carry the 2. 4 times 2 is 8 plus 2, which is 10. We did the first part. We'll cross out our 4 because we don't need it. We'll add a 0 on the bottom to show that we've used that place. 1 times 7 is 7, and 1 times 2 is 2. When we add our partial products, and I'll do it up here, 8 plus nothing will give me 8, 0 plus 7 will give me 0, and 2 plus 1 will give me 3. Now again, we had 2 numbers on the right of our decimal, so that means I'm going to start here and swing it 1, 2 to the left and place my decimal there. Therefore, my answer is 3.78. I'll do the same thing with the other one. Again, I'm going to ignore the decimals. So instead of 2.5, it's really just 25. And instead of 0.5, it's just 5. So 5 times 5 is 25. I'll put my 5 down, carry my 2. 5 times 2 is 10 plus 2. That gives me 12 for a final product of 125, but I'm going to see I have one number behind the decimal, one number behind the decimal. That's 2, so I'm going to swing it twice, and of course what I end up with is 1.25, 1.25. Now that's what's happening here in the area model. They're just kind of representing it a little bit differently. So in the area model, what's happening is this 0.5 is being distributed to this 2.0. It's also going to get distributed all the way to this other 0.5 as well. And when we multiply, we'll get a partial product and then another partial product, and then we'll add them for our final product. So ignoring the decimals, I have 20 times 5. That's going to be 0. 5 times 2 is 10. So now I have 100. One number behind the decimal here, another number behind the decimal here, that's 2, so I'm going to swing it 2. And so I really have one, let's say, dollar, 1 and 0 hundredths. I'll do the same thing with 0.5 times 0.5. I'm going to ignore the decimals and just say it's 5 times 5, which gives me 25. But of course I have a number on the right side of the decimal and a number on the right side of the decimal, so I'm going to swing that to the left, 1, 2, and I have 25, or 0.25 rather. Then I'm going to add my partial products. So I should have 125, exactly how it looks up here. And what I'll do to show you just a little bit more visually is this is going to represent our 25. If you count the squares in the row, you'll see there's 5 going up and down and 5 going straight across. That means that's 5 rows of 5 little unit squares in it, which gives us a total of 25 little unit squares. Here we have 5 rows of 20 squares each, and so that will give us 100 unit squares as well. So yeah, That's how it's represented through area model. But moving on, we're going to be focusing on the standard algorithm, which is what I actually prefer. Okay, so again, when you multiply, you're going to ignore the decimal point at first, okay? Then, what do you call it? Then you'll add it at the end. For this next part, though, it says multiply the digits as usual, ignoring the decimal point. There is no need to line up the decimal if you are setting it up vertically. And that's why we don't do that, because otherwise you line up your decimals and it gets a little bit more complicated than it needs to be. It says the product will have the same number of digits to the right of or behind the decimal as the multiplicand and the multiplier combined. Okay, so whatever you're multiplying, however many numbers are behind that decimal, that's how many times you're moving the decimal. Here, we're going to determine how many digits are behind the decimal. We're not even going to solve it. Here I see 1, so my answer is 1. Here I see 1, 2, 3, 4, so my answer is 4. Here I only see 1, 2, so my answer is 2. And here I see 1, 2, 3, so my answer is 3. Okay, that's how we're gonna find out what we need, or how many times we need to move our decimal point. Also, you'll see that I highlighted the word round and estimate, right? So we use estimation to check for what's called reasonableness. Okay, we do this all the time. Sometimes if it's like 3:58 in the afternoon, someone will ask you the time, or you'll ask someone for the time and they might just say 4 o'clock, right? Because we're rounding up and we're being reasonable with how we're rounding. So as you can see, we're going to round 1.9 up to 2. So instead of 1.9 times 6, we have 2 times 6, which is 12. 94, we can round to the nearest dollar. So that'll be 1 whole times 5, which will get us close to 4.7, but really it's just 5. Now, 7 will tell my 5 to go up. So it becomes 6 times 11, which is 66. Now there's a rule here that you can use. 4 or less, let it rest. 5 or more, add 1 more, which is exactly what we did here. Since that was 5 or more, we added 1 more there, and everything after it, add 1 more, became a 0. Okay, so that's a 6. That's how we round. That's how we use some reasonableness. Okay, let's keep going. Okay, this part's pretty simple, especially since we're using a grid. So again, we're going to ignore the decimals for now. I'm going to write 68 times 3. 3 times 8 is 24. Put down your 4, carry your 2. 3 times 6 is 18 plus 2. We get 20. How many numbers are on the right of the decimal? Just 1. So we swing it over once, and we place our decimal there. Do the same thing with the next one. We have 15 times 7. 7 times 5 is 35. Put down the 5, carry the 3. 7 times 3 is 7, plus 3 is 10. We have 1 number on the right of the decimal sign, so we swing it over once, and we place our decimal there. 10, we have 41 times 5. 5 times 1 is 5, and 5 times 4 is 20. This time, though, we have 2 numbers on the right of the decimal, so we're going to swing it over twice. For the next one, we're going to ignore these decimals until the end. 208 times 9. 9 times 7 is 70, or 9 times 8 rather is 72. Put down the 2 and carry the 7. 9 times nothing is nothing, plus 7 is 7. And 9 times 2 is 18. We have one number on the right of the decimal, so we're going to swing it over one time and place it there. Our answer here is 187.2. Next one, we have 719 times 22. 2 times 9 is 18. Put our 8 down, carry the 1. 2 times 1 is 2 plus 1 will give us 3. 2 times 7 is 14. I'm going to cross out my 2 because I'm done with it. Put a 0 as a placeholder to show that I've used that ones place. 2 times 8 is 18. Carry the 1. 2 times 1 is 2 plus 1 is 3. 2 times 7 is 14. We're going to add our partial products. 8, 11, 8, 5, 1. Now in this case, we have 1, 2, 3 numbers behind the 0. So I'm going to move it 1, 2, 3 places. My answer is 15.818. When I go to 13, again, this is pretty basic stuff here where it's 1 by 4-digit multiplication. Of course, if I write the right number, that'll work. 5 times 3 is 15. Carry the 1. 5 times 5 is 25 plus 1 is 26. Put the 6 down, carry the 2. 5 times 1 is 5 plus 2 is 7. And 5 times 1 is 5. We have 2 numbers on the right of the 0, so we swing it over 2 to the left. Our answer is 57.65. Let's keep on keeping on. A little bit closer. All right. Here it says Amber walks her golden retriever 1.87 miles each day. She works 5 days a week. So how many miles does Amber walk her golden retriever? All right, that's not too bad. We can do that. I'm going to get my 187. I'm ignoring the decimal. I'm going to multiply it by 5 because that's how many days a week she walks her dog, that 1.87 miles. 5 times 7 is 35. Put the 5 down, carry the 3. 5 times 8 is 40 plus 3 is 43. Put the 3 down, carry the 4. 5 times 1 is 5 plus 4 is 9. There are 2 digits on the right of the decimal, so we swing it over twice to the left. She walks her dog 9.3 miles every week. Okay, Fuji apples are $1.79 per pound. Hayden purchases 3.45 pounds of apples. What will the total price of his purchase be? And it also says to round to the nearest cent, aka the nearest penny. Okay, let's do it. Again, we're going to ignore the decimals, so basically we're just multiplying 179 times 345. 5 times 9 is 45. Put your 5 down, carry your 4. 5 times 7 is 35 plus 4 is 39. Put their 9 down, carry the 3. 5 times 1 is 5 plus 3 is 8. Cross that out, put a 0. We don't need these. 4 times 9 is 36. Put the 6 down, carry the 3. 4 times 7 is 28 plus 3 is 31. Put the 1 down, carry the 3. 4 times 1 is 4 plus 3 is 7. Cross that out, put 2 zeros to take the place of these place values. 3 times 9 is 27. Put the 7 down, carry the 2. 3 times 7 is 21 plus 2 is 23. Put the 3 down, carry the 2. And 3 times 1 plus 2 is 5. Then you add your partial products. I'll obviously add them up here since I'm out of space. 5 plus nothing is 5. 9 plus 6 is 15. Put your 5 down, carry your 1. 8 plus 1 is 9, plus another 1 is 10. 10 plus 7 is 17. Put your 7 down, carry your 1. 7 plus 3 is 10, plus 1 is 11. Put your 1 down, carry your 1. 5 plus 1 is 6. There you go. But we have 1, 2, 3, 4 numbers behind the decimal. So I'm going to move it 1, 2, 3, 4 and place my decimal here. So I have 6.17. But again, they want me to round to the nearest cent, to the nearest penny. So what I'm going to do here is I'm actually going to look at the number behind my 7 because that generally tells my 7 what to do. Now, based on what we just learned, if it's 4 or less, we let it rest and everything else becomes a 0. But if it's 5 or more, we add 1 more. And when we do that, we actually end up with 6.18, which in this case would be the correct answer. All right, we're almost done. Let's keep going. It says Sydney and Jorge solved the problems below, or as shown. Who made a mistake, and what should the correct solution be? Okay, well, let's start with Sydney. Ignoring the decimals, I'm going to do 628 times 37. 7 times 8 is 56. Put your 6 down, carry your 5. 7 times 2 is 14, plus 5 is 19. Put your 9 down, carry your 1. 7 times 6 is 42, plus 1 is 43. Cross out your 7. Put a 0 to show that you've used your ones place. We're ready for part 2. 3 times 8 is 24. Put your 4 down, carry your 2. 3 times 2 is 6, plus 2 is 8. And 3 times 6 is 18. When you add your partial products, you'll get 6. 13, carry your 1. 12, carry your 1. 13, carry your 1. And finally 2. We had 1, 2 numbers. We're going to swing it over twice. And as you can see, what we got, 232.37, is not the same as what they have here. So Sydney made the mistake. I'm not sure where she got this 0 from, but she should have swung it once, twice, and placed the decimal right there. Since we're comparing 2 different students and only one of them got it wrong, we're going to assume that Jorge did it correctly. If you were to do the math, you'll see that Jorge does it correctly. And that's how we multiply decimals.